Hi guys, so in this video lecture, we are going to cover the second part of the analytical process involving moment. Okay, so similar with the previous lecture series, we are going to divide this particular lecture into three smaller segments, including moment about an axis, couple and equivalent moment, and finally simplification of the force and couple systems. In certain engineering application, we are more interested to know the magnitude of the moment about an axis. Okay, before this, you studied about the moment in reference to the rotation point. Okay, this time around, we are going to look into the tendency of the rotation about an axis. Benda pula tu. Okay, let's look at this few compilation of crane field cases to understand the concept of moment about an axis. So as you can see here, oh god, dia jatuh ke the bush. That's catastrophe. And look at this mobile crane. Tergolek pula dia. Boom. The video shown is example of mobile crane which is being used to lift loads during construction. So the crane consists of multiple bays, let's call it point A and point B, which is being used to support the crane during its operation. Let's say the XY axis is as shown. If you notice, the tendency of the mobile crane to tergolek tu is forming a kind of rotational motion along an axis. If the load is too high, then there is the tendency for the crane to topple over an axis. In this case, the Z-axis which passes through the A and B point. Direction of Z-axis ni macam terkeluar dari screen. So, to investigate for this kind of problem, it is necessary for us to understand how we can calculate the moment about an axis. So if you look at this figure, the wrench is being used to loosen the nut of the tire. So in order for you to loosen the nut, you are going to apply some kind of force onto the wrench. So based on the previous application of moment, sebelum ni formula dia is moment equals to FD, whereby the D is the perpendicular distance from the rotation point O to the line of F. The distance would be from the rotation point O to the line of F here, over here as I sketch here. So the corresponding axis of the moment would be over here. And the direction of the moment would be like this, okay? But you have to remember, the nut of the tire, there's like 4 nuts over here, restricts the motion of the moment. Meaning it will restrict the rotation to only happen in the y direction only. So in this case, the consideration of the D in the moment formula would be slightly different from the one we used in the previous formula. When involving a specific axis, the moment formula along an axis would be F multiplied with dA, whereby the D is respective to the axis. Okay, so in this case, in the nut punya case ni, we can also rewrite the equation as my, because the rotation point that we want to know is in the y-axis kan. So my is equivalent to F multiplied with dy. So what is so special about this D in the rotation about an axis is that you have to make sure that the distance is perpendicular or 90 degree to both the line of force, the F, and also the rotation axis. In this case, the rotation axis is Y. So the D that we need to use instead is this D, which is 90 degree to the line of axis, which is Y-axis, and also 90 degree to the line of force, okay? If you look at this example, you are required to find the corresponding moment about axis X and the moment about axis Y and also the moment about axis Z. So if you recall the formula that we covered earlier, the moment about respective axis MA should be equivalent to F multiplied with the distance to the respective axis D axis. Let us first solve this problem along the x-axis first. So in order to easily visualize the direction and the distance of the force, so you imagine like you're standing exactly at the x-axis looking forward like this. Okay, this is your mata lah. Okay, so in a 2D scale, this is how the line of force would look like. Okay, you have the crate over here, and then the F1 would be in this direction, and F2 would be at this point and this direction. Okay, now the distance for the first force should be perpendicular to the line of force and also to the line of axis like this. So D1 is going to be 0.6 meter. Accordingly, the perpendicular distance of force 2 should also be perpendicular to its line of force and also the line of axis like this. So the D2 in this case would be 0.6 meter as well. Okay, so now you can calculate the magnitude of moment along x-axis by multiplying this combination of force F1D1, and also you see there's another force over there which is F2, and it have to be multiplied with the D2. Okay, now look very carefully. What is the direction of this force along the rotational axis? So if you look at F1, you draw an imaginary circle with the O as the center point. So you will get this kind of moment direction. So the moment direction would be in a counterclockwise direction lah, sebab lawan jam kan. So if it is counterclockwise, we assume it to be positive. So accordingly, kalau kita buat the same imaginary circle for the second force, we will also get the counterclockwise direction. So the magnitude for this combination would also be positive. So you just substitute the value F1 60 Newton, D1 is 0.6 meter, and then F2 is 50 Newton and D2 is 0.6 meter into your equation. So you will get a corresponding magnitude of 66 Newton meter. What is the direction? So if you notice, the magnitude of your moment along the x-axis is positive notation. Kan? So if it is positive, then the direction is a counterclockwise direction. And now you repeat the same process for the y-axis pula, okay? I'm going to fast forward this particular section. You try to do it on your own. And lepas you dah buat the draft sketch, you dah kira, substitute all the value of the F and the D, you will get a corresponding moment along the y direction to be negative 6.9 Newton meter. Okay, saya ada tersilap tulis kat situ. You should write it as my, not mx. Okay, so kalau magnitude dia is negative 6.9 Newton meter, you can also rewrite this expression as 6.9 Newton meter, but the direction is clockwise direction. Now we are going to repeat the same process along the z-axis as well. Let me just delete this chonteng-chonteng on the picture here. So again, imagine that you are standing along the z-axis looking straight forward, and this is how the box of crate should look like, and the direction of force would be like this. So this is the point B. So F2 is going into the direction of the z-axis. So you cannot actually see the line of force over here. So we don't have to include it in our sketch. Okay. The F3 would be at point C, and the location will be over here, and the magnitude would be 40 Newton, while F1 would be at point A, which is at this particular point, which have a magnitude of 60 Newton. Okay, now we have to find the perpendicular distance from the line of force to the line of axis, which in this case is a z-axis. So for F3, the D3 would be from the line of force 90 degree and also 90 degree to z-axis, and it will be from here to here. So D3 would be 0.6 meter. Okay, now look carefully for the F1. Kalau you tengok F1, it actually passes through the rotation point O. Although it can form a distance 90 degree to the line of rotation, but to the line of force, dia tak boleh nak create 90 degree, it becomes 180 degree instead. So in this case, you cannot identify what is the D1 distance along the z-axis. So your D1 in this case would be 0. Okay, now accordingly, if you want to calculate the moment along the z-axis, okay, let's assume the counterclockwise direction as positive. So kita ada F1 D1 combination over here, and we also have F3 D3 combination over here. So kalau tengok F1 D1 ni, they won't create any kind of moment rotation lah. So you can just neglect the magnitude lah, whether it is positive or negative, it will always get 0 juga, okay? Because the line passes through the rotation point. But F3 D3 ni, if you create an imaginary circle around the rotation point O, then it would be in a clockwise direction, arah jam. Look very carefully. So if the direction is clockwise, then the magnitude of F3D3 would be negative. Okay, so you just substitute the value of F1 60 Newton, D1 0, and then F3 is 40 Newton, and D3 is 0.6 meter. Use your calculator, and you will get the corresponding magnitude for the moment along the z-axis to be negative 24 Newton meter. So you can also rewrite this answer as 24 Newton meter, and don't forget to include the direction as well. So kalau negative, it means the overall direction would be in clockwise direction. Okay, so dah siap. Not all engineering mechanics problem can be solved simply using the scalar formulation. So most of the time you need to consider using the vector formulation to solve the problem. In this case, let us try and use the same wrench nut tire example. Okay, so similarly, there is a force from your hand trying to turn the wrench so that the nut can be turned as well. So kalau sebelum ni, if you want to solve this kind of problem using the vector formulation, then the vector moment can be calculated by using the cross product, whereby position vector R cross product with the force vector. The direction of the position vector R would be from the rotation point O to any point along the line of force, like this. So, similar like previous scalar example, you will get a corresponding moment axis at this highlighted area. Okay, this is your moment direction axis, and your moment would be like in a counterclockwise ke clockwise ke, depends on the direction of the axis. Okay, now if you want to measure the moment along a very specific axis, then we can calculate the magnitude. Okay, notice the magnitude using the same cross product expression. Okay, magnitude of moment along an axis would be equivalent to R cross product with the F. Okay, position vector cross product with the force vector. Tapi jangan lupa untuk dot product this entire cross product operation with the unit vector along the axis that we want to study. Okay, we can rewrite this expression in a metric form, whereby the first layer would be the magnitude of the unit vector along the respective axis, so UAX, UAY, and UAZ. The second layer would be the magnitude of the position vector respective to its direction lah, RX, RY, and RZ. And finally, the third layer would be the magnitude of the force along its respective direction, Fx, Fy, and Fz. Okay, so using this formula, you can attain the magnitude of the moment. Tapi in certain cases, we want to know what is the direction of the moment. So you need to calculate the Cartesian vector of this particular moment. So kalau you notice, similar with the force punya formula, the vector of the moment along an axis can also be calculated by multiplying magnitude of the force along an axis. Okay, let's use MA in this case to differentiate between the common moment. Okay, now in order to get the vector of the moment along a very specific axis, you need to multiply the magnitude of the moment, MA, multiply with the unit vector along the axis that we want to study. Okay, so there are two parameters that you can attain, which is number one, magnitude of the moment along an axis, and you can also get the Cartesian vector expression of the moment about an axis. Okay? Okay, so in this example, you are required to find what is the vector moment produced by force F, which tends to rotate the rod at AB axis. So this is the AB axis and this is the direction of the force. So how are we going to solve for this kind of problem? So based on the previous formula given to you, the magnitude of the moment about the specific axis can be calculated by multiplying the unit vector of the axis dot product with the R position vector cross with the F vector. And if we want to get the Cartesian vector of the moment, we can multiply the magnitude of the moment with the unit vector along the axis. So the axis yang kita nak study ni is the AB axis kan. So the magnitude along the AB axis can be calculated by multiplying unit vector along the AB axis dot product with the position vector R cross with the force vector. Okay, recall from the previous lecture, the unit vector can be calculated by dividing the position vector of AB axis 2 with the magnitude of the position vector. So nak dapatkan position vector, macam biasa kita dapatkan dulu the coordinate of A and coordinate of B. So A is the origin, so the coordinate is 0, 0, 0. And B, the coordinate for B is 0.4 positive on the X direction. And then 0.2 positive in the Y direction. And along the Z direction tu tak ada tau. So it will be 0. So you can rewrite the position vector of AB to be 0.4I plus 0.2J plus 0K. So kalau tak tulis K tu pun tak apa. Okay. The unit would be in meter. So you have to divide everything with the magnitude of the position vector. So saya buat straight away lah dalam satu formula. Okay. So the magnitude is 0.4 squared tambah dengan 0.2 squared. And you have to square root all this expression. Okay, so you should be very familiar with this operation. I'm going to fast forward this particular segment, and the corresponding unit vector along the AB axis would be 0.8946 in the direction of I plus with 0.4472 in the direction of J. So that vector is the unit vector along the AB axis. Now that's done. Okay, based on the given formula, the next thing that we need to look for is the position vector. So the position vector can be at any point from the rotation axis to the line of force. Okay, so just to make my calculation much easier, so I'm going to select the position vector R to be from here to here. Okay, so the coordinate, the new coordinate for my position vector would be in the X direction is 0.6I, along the Y is 0, and then along Z also 0. So if there is a lot of 0, then you know my cross product calculation will be so much simpler. So if I were to convert this coordinate into an equivalent position vector, then it will become 0.6I je lah. Okay, so the R is done. The next thing we need to look for is the force vector. Okay, you can calculate the force vector by multiplying the magnitude of the force with the unit vector of the force punya line tu tau. Tapi kalau kita tengok from the force punya direction ni, it's quite straightforward lah. It only happens along the z-axis je kan. So sebenarnya you boleh agak lah, the force vector of this particular line of force would be negative 300 because negative sebab it is pointed downwards in the K direction. Itu sahaja. Okay. IJ semua tak ada sebab dia memang straight along the z-axis only. So the unit of this force vector would be in Newton. Okay, so kita boleh proceed to calculate the magnitude of the moment by multiplying the unit vector along the axis with the cross product of the position vector and the force vector. So remember, you can actually simplify this equation by writing it in matrix form. The first layer would be all the magnitudes of the unit vector along the AB axis. So kalau tengok dekat sini, it would be 0.8946, and then the second column is 0.4472, and at the K direction tak ada, so you tulis 0. And then the second layer would be all the magnitudes in the position vector punya expression. So position vector ni dia ada dekat 0.6I je. So this is 0.6. On the J layer would be 0, and on the K column would be 0. And then finally the third layer would be all the expression in the force vector. So force vector ni expression dia cuma ada dekat K je, which is over here, negative 300. Whereas the I and the J is kosong and kosong. Okay, look very carefully how we are going to solve a combination of a dot and a cross product equation. Okay, first you take out the first expression on top of the layer, which is 0.8946, and this is the magnitude in the I direction. Okay, lepas tu you buat another bracket, barulah you apply the cross product operation. So if you remember, kalau kita nak calculate the cross product of the I punya column tu, imagine kita tutup column I tapi kita buat cross dia dekat J and K. So in this case, 0 multiplied with negative 300 and 0 multiplied with 0. It becomes 0 lah. Banyak benda when multiplied with 0 becomes 0. And then as for the J expression, it always start with a negative value. Okay, so letak negative dekat sini. And then you take out the topmost layer punya magnitude tu, which is 0.4472 J. So you have to dot product with the second and the third row punya lah. So 0.6 multiplied with negative 300 tolak dengan 0 multiplied with 0. So 0 multiplied 0, 0 lah. So saya biarkan dia as it is. And this is the magnitude in the J direction. And then accordingly in the Z direction, kita kembali kepada positive. And then you take out the topmost layer. In this case is 0. And then the direction is K, and then you dot product with the second and the third row, which is 0.6 multiplied with 0 and 0 multiplied with 0. So sebenarnya you akan dapat kosong jugalah for the K direction. Now, if you can recall from your previous algebra mathematicnya kelas tu kan, so I product dot with I product is equivalent to J dot J is equivalent to K dot K, and you will get magnitude of 1. Okay, so this is very important in our calculation over here because it involves a dot product operation. Okay, so looking back into our equation, 0.8946 dot with 0 or multiplied with 0 akan jadi 0 lah. I dot I akan jadi 1. So, even kalau kita tak letak dalam equation pun tak apa. And then, the second expression, negative 0.4472 multiplied with 0.6 multiplied with negative 300, you will get a magnitude of negative 180, and J dot with J, remember, akan dapat 1. So, even kalau saya tak letak pun tak apa. Dia akan jadi a single unit. And the third expression is 0 multiplied with 0 akan dapat 0, and then K dot K will become 1. So, you total up this value and you will get the corresponding magnitude along the AB axis to be 80.496. What is the unit? The position vector tadi is in meter and the force vector tadi is in Newton. So, the unit for your moment would be in Newton meter. So accordingly, we can also calculate our moment in a Cartesian form, whereby the moment in Cartesian form would be equivalent to magnitude of moment multiplied with the unit vector of that particular axis. Magnitude of moment tadi kan kita dah kira, which is 80.496 Newton meter. I'll just rewrite it again. And then the unit vector about the AB axis pun kita dah kira, which is over here. Okay, this one. So we have to multiply it with 0.8945I plus 0.4472J. So 80.496 multiplied with 0.8946, I'll get 72.0117 I direction. Okay, I tak hilang ya di sini. And then 80.496 multiplied with the 0.4472, you will get a value of 35.9978 J. So this is the vector form of your moment about the AB axis, and the unit is correspondingly Newton meter. So dah siap.